Happy Tuesday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Over the next couple of days, I will be looking at everybody's tests that they've taken and going through to see if there's any more points I can give you partial credit. Some of you submitted your work and I'll take a look at that anyway, but I'll have those final grades done after a couple of days anyway. But today we're going to go on and take a look at chapter 7. We're going to cover section 7.1 and 7.2 today. So tonight you've got those two homework assignments. So let's go ahead and get started. This is section 7.1. It says simplifying rational expressions. A rational expression is basically an algebraic fraction. It's a fraction that contains at least one variable. Anyway, so we're going to look at simplifying rational expressions. First of all, I want to ask you some questions here. Let's see. X minus 8 divided by x minus 8. What do you think that would simplify down to? X minus 8 divided by x minus 8. Anybody? No, nobody's going to participate. Fine. Well, isn't x minus 8 the same thing as x minus 8? A number divided by itself other than 0 divided by 0 would equal 1. What about x plus 8 divided by 8 plus x? Well, addition is commutative, so x plus 8 is equal to 8 plus x. So again, this is equal to 1. What about this? X minus 8 over 8 minus x. What does that equal? Or how about this? X plus 8 over x. What does that equal? Well, we're going to find out that this doesn't simplify and that this is equal to -1. And let's take a look. We'll come back to that in just a bit. All right, let's see, I've got the following. 3x minus 2 divided by x minus 2. And it says, evaluate each expression for x equals 6. So we're going to take this fraction and every place that x appears, we're going to replace it with the number 6. So we're going to get 3 times 6 minus 2 over 6 minus 2. Which is 18 minus 2 over 4, which is 16 over 4, which is 4. So the value of this expression when x is 6 is 4. Any questions about that? All right. How about this one? X squared minus 36 over x cubed minus 1. Again, it says evaluate the expression for x equals 6. So I get 6 squared minus 36 over 6 cubed minus 1. 6 squared is 36. 36 minus 36 is 0. 6 cubed, let's see, what is that? 6 times 6 is 36 times 6 is 216 minus 1. So that would be 215. What's 0 divided by a non-zero number? That is 0. One more example here. Let's say I've got negative 2x squared minus 3 over x minus 6. And again, we want to evaluate this expression for x equals 6. So in the numerator, we get negative 2 times 6 squared minus 3, which is negative 2 times 36 minus 3, which is negative 72 minus 3, which is negative 75. In the denominator, we get 6 minus 6, which is 0. And dividing by 0 is undefined. So, a 0 number divided by a non-zero number is 0. A non-zero number divided by 0 is undefined. So don't forget about that. All right, now, this next set of problems, it says, find all real numbers for which the rational expression is undefined. In other words, for instance, what value or values of x make this thing such that you're dividing by 0 so that it's undefined? Well, what makes the denominator 0? Let's take the denominator and set it equal to 0 and then solve it. Well, if we added 2 to both sides, we get x equals 2. So for instance, if x is 2, we'd get 15 over 0, which is undefined. So back to the question, find all real numbers for which the rational expression is undefined, x equals 2. Okay. How about this one? 5x over x plus 5. For what real number or real numbers would this thing be undefined? For x equals -5, right? Because then the denominator would be 0. How about this one? 4x minus 1 over 6x. When would this be undefined? When x equals 0, right? Because you'd have what? 4 times 0 minus 1 or -1 over 0. Okay. Questions there? All right. How about this one? X squared minus 4x over x squared plus 4. Well, x squared plus 4 equals 0. When is that going to happen? Well, not for any real number, right? Because you'd have to have x squared equals -4. Positive times positive is positive. 0 times 0 is 0. Negative times negative is positive. So there's no real number which would make this thing 0. So there's no restriction. So for what? Find all real numbers? None. Okay, now the directions say simplify. Let's say we have 48 over 16y. We could reduce 48 over 16 by dividing the top and the bottom both by 16, and we get 3 over 1 times y. So we get 3 over 1y, or just 3 over y. How about 9x cubed divided by 6x? 9 over 6 reduces to 3 over 2. X cubed over x reduces to x squared over 1. So we get 3x squared over 2, or you could write it 3/2 x squared. How about this one? 4x plus 12 over 16. Here's where we need to be careful, okay? We can't reduce this, and we can't reduce that. Why not? Because in the numerator, these are terms, they're not factors. So what do I mean by all of that? Well, if I split it up, I could reduce them both. Or another way I can reduce them is to do this. We could take the greatest common factor out of the numerator. Now, 4 is a factor of the numerator. X plus 3 is a factor of the denominator. I can come in, excuse me, x plus 3 is also a factor of the numerator. So 4 is a factor of the numerator. X plus 3 is a factor of the numerator. I can now reduce the 4 over 16 to 1 over 4. So I get x plus 3 over 4. I can't come in and reduce that or reduce that because these are terms. You can't reduce terms. You can only reduce factors. That's the big deal about this chapter that you need to grasp. How about this one? 2x minus 14 over x minus 7. You might think, well, 2x over x is 2, and minus 14 over minus 7 is a positive 2. But you can't do that because the numerator and the denominator are both made up of terms. But we could do this. We could factor the numerator. So now the factors of the numerator are 2 and the quantity x minus 7. And the whole denominator, x minus 7, is a factor. So now I can reduce those, and I get just 2. Any questions about that? All right, let's take a look at this one. Y squared minus 25 over y squared minus 3y minus 10. Y squared over y squared, you can't do that. Y squared over 3y, you can't do that. 25 over 10, you can't do that because they're all terms. But we could turn them all into factors by factoring the numerator and factoring the denominator. I get this. Now I can reduce out common factors. So my final answer becomes y plus 5 over y plus 2. And I can't reduce the y's in that final answer because the y's are not factors, they're terms. Okay, how about this one? Let's see how I'm doing here. We've got 11c squared minus 11d squared all over c squared minus 2cd plus d squared. So basically I need to factor things before I can reduce them. Let's see, the numerator, I could take out a greatest common factor of an 11, and then I could factor further the difference of 2 squares. In the denominator, I believe this is a perfect square. So again, I could write it like this, and then taking out the greatest common factor of both common factors. And I end up with 11 times c plus d over c minus d, okay? Or you could write it 11c plus 11d over c minus d, either one of those. Okay, what about this? 6 times d plus 3 minus 6 over 7 times d plus 3 minus 7. You might think that you could reduce out the d plus 3's, but they aren't factors of the entire numerator and of the entire denominator. So we can't do that. What we have to do is distribute 6d plus 18 minus 6, 6d plus 12, 7d plus 21 minus 7, 7d plus 14. But now I could factor a 6 out of the entire numerator and a 7 out of the entire denominator. Do you see the difference between this and that? So now I can cross out, reduce down the common factors. Final answer, 6/7. Let's take a look at this scenario. 7 minus 2 over 2 minus 7. What is 7 minus 2? It's 5. What is 2 minus 7? It's -5. What is a number other than 0 divided by its opposite? What's 5 divided by -5? It's -1. All right. How about 10 minus 7 over 7 minus 10? 10 minus 7 is 3. 7 minus 10 is -3. 3 divided by -3, a number divided by its opposite is -1. Notice the pattern here. If we subtract two numbers, switch the order and subtract them, we get the opposite of the first number. A number divided by its opposite is -1. So what about this situation? 18 minus d over d minus 18. Isn't that a subtraction divided by a subtraction? Those would produce opposites. So the answer is -1. Any questions about that? Okay, how about this one? 5t minus 1 over 3 minus 15t. Well, I could rewrite the denominator, factoring out a 3, and I have 5t minus 1 over 3 times 1 minus 5t. But take a look at that combination. Isn't that a number divided by its opposite? So those would reduce down to -1. So now I've got -1 over the 3 that was still in the denominator. Okay, let's see here. How about this one? 4 minus b over b squared minus 5b plus 4. That is 4 minus b over, let's see, b minus 4, b minus 1. So here again, we have that special situation. That over that reduces to -1 over 1. So I've got -1 over the quantity b minus 1. Or you could write it negative the quantity b minus 1. Okay. Any questions there? One more example of that. 36 minus 6h over h squared minus 36. Well, let's see. In the numerator, I could factor out a 6, and I'd have 6 minus h. In the denominator, I've got what? H plus 6, h minus 6. There's that combination again that reduces down to -1 over 1. So now I've got -6 over h plus 6. So we want to look for that pattern. Sometimes it appears unexpectedly. Okay, let's see. How are we doing for time? We've still got time to stay in this section. It says simplify. If an expression cannot be simplified, write does not simplify. 2c to the 4th plus 2c cubed over 4c to the 5th plus 4c to the 4th. Well, in the numerator, I could take out the greatest common factor, which is 2c cubed, and have c plus 1 left over. In the denominator, I could take out the greatest common factor, which is 4c to the 4th, and have, let's see, what would that be? C plus 1 left over. Is that right? I think so. Well, the c plus 1's reduced down, but so does the 2 over 4 to 1 over 2, and the c cubed over c to the 4th to 1 over c. So what have I got left? 1 over 2c. Any questions about that? All right. How about this one? X squared plus x minus 6 over x squared minus x minus 2. I have to factor it before I can reduce. The numerator, let's see. Product is -6, sum is 1. How about plus 3 and minus 2? The denominator, product is -2, sum is -1. How about -2 and plus 1? Reducing out the common factors, we get x plus 3 over x plus 1. Let's see here. How about this one? A plus b over 5b plus 5a. That would be a plus b over 5 times b plus a. But a plus b is equal to b plus a. Addition is commutative. A number divided by itself reduces to 1 over 1. So I've got 1 over 5. Be careful. That's not that opposite situation. Okay, let's see. How about this one? 2x squared minus 8 over 3x squared minus 5x minus 2. In the numerator, I can take out the greatest common factor and then factor the difference of 2 squares. In the denominator, let's see, I need to write that so it looks a little better. Okay, now, where did I get that one from? There we go. Let's see, this is going to be a 3x and an x and a 2 and a 1 and a minus and a plus. And then we're going to get what? 3x plus 1, x minus 2. The common factors to reduce out are the x minus 2's. So we've got 2 times x plus 2 over 3x plus 1, or 2x plus 4 if you wanted to distribute back in the numerator. Okay. How about this one? 25m squared minus 1 over 5m plus 5. In the numerator, we have 5m plus 1, 5m minus 1. In the denominator, we have 5 times the quantity m plus 1. This does not simplify. We can pull it apart, but there's no common factors to reduce out. Okay, I'm getting ready to go to 7.2. Any questions before we go on? All righty, here comes section 7.2, which is multiplying and dividing rational expressions. Let me refresh your memory as to how we multiply or divide when we've got some nice simple fractions. Let's say we've got 3/7 times y over 2. Nothing pre-reduces, so we just multiply straight across. Or if we've got 2/7 times z over 3, we get 2z over 21. What if we have something like this? 3/7 times y over 6. Well, then we can sort of pre-reduce this 3 and the 6 and reduce that down to what, a 1 over 2. Oops. So then we get what? 1y over 14. Okay. What about this situation? Got y plus 2 over y times 3 over y squared. Well, I can't really reduce anything out ahead of time, so I'm going to have 3 times y plus 2 over y cubed, or 3y plus 6 over y cubed. There's no common factors in the numerator and the denominator that we can reduce out. What about this situation? 11m over 21 times 14 over 55 m cubed. Well, 14 over 21 reduces to 2/3. 11 over 55 reduces to 1/5. M over m cubed reduces to 1m squared. And I've got what? 1 times 1 times 2 over 3 times 5 times m squared. So 2 over 15 m squared. Again, any questions there? All righty. How about this situation? A minus 9 over 9 times 8a over a minus 9. The common factors of a minus 9 reduce out, and we're left with 8a over 9. My a's and my 9's look an awful lot alike. 8a over 9. Okay. What about this situation? 5z minus 10 over z plus 2 times 3 over 6 minus 3z. Let's take this thing and let's factor everything first. So let's take that first 5z minus 10 and take out the greatest common factor. 6 minus 3z, take out the greatest common factor. Well, let's see. The 3's would reduce out. What about this? That's that -1, isn't it? So -1 over 1. And what have I got left? So on top, I've got 5 times -1 times 1 is -5. And in the denominator, I've got z plus 2, and that's it. Or I could write it like this, putting the negative or the minus sign out in front of the whole thing. Okay. How about this situation? Z squared plus 4z minus 5 over 5z plus 5 times 5z over z plus 5. So I'm going to factor each numerator and denominator completely. First of all, let's see, I get z and plus 5 and minus 1. Greatest common factor in the denominator is a 5 with a z plus 1 left over. 5z, z plus 5. Okay, so what can I get rid of? Well, the z plus 5 is reduced to 1 over 1. The 5 over 5 reduces to 1 over 1. And in the numerator, I have z times z minus 1. In the denominator, z plus 1. Or again, I could distribute and z squared minus z over z plus 1. So either this or that. Trying to find. Oh. Okay. Well, I see what happened. I copied it wrong. That's why I got a different answer. Let's do a different version of this problem. It's going to change everything. This problem, I believe, is correct as I did it. But we're going to go back and do a different problem. Let's put a minus sign here. That's what the problem is supposed to. Let's see what happens now. Well, in the numerator, we have a z and a plus 5 and a minus 1. In the denominator, we have a 5 and a z minus 1. Over here, 2z, z plus 5. Okay, that changes everything. These reduce down. These reduce down. Those reduce down, and we just got z left. Yeah, anyway, the previous problem, I believe the answer was correct for the problem, but I just didn't write it down correctly. Okay, how about, let's see here, we're still good with time. How about this one? M squared minus 2m minus 3 over 2m plus 4 times m squared minus 4 over m squared plus 3m plus 2. So again, you might think, oh, the m square on top and the m square on the bottom reduce out, the 2m and the 2m on the bottom, the 4. No, they don't reduce out unless they're factors. So the first thing we're going to do is factor everything. This is going to be an m, and a minus 3 and a plus 1. This is going to be 2 and an m plus 2, taking out the greatest common factor. This is the difference of 2 squares. And this is going to be an m and an m plus 2 plus 1. So everything's factored completely. Let's see. I could get rid of an m plus 2 and an m plus 1. I think that's it. So now I've got m minus 3 over m minus 2 over 2 times m plus 2. Okay. And you could leave it like that, or you could multiply it all back out, but I wouldn't bother unless they specifically ask you to. Let's see, how about this? 9p times 10 over 9p. Keep in mind that 9p is like 9p over 1. So you could reduce out the p in the numerator and the p in the denominator, and you'd end up with 90. Okay. How about this one? 28 times 8 minus 3t over 4t. Well, we could reduce the 28 and the 4 to 7 over 1. And now we have 7 times 8 minus 3t all over t. Or you could write it, what, 56 minus 21t all over t. Either way would be correct. Now, we've looked at multiplying algebraic fractions or rational expressions. What about dividing? Well, recall when you divide one fraction by another, it's the same as multiplying by the reciprocal of the divisor. So 2/3 divided by 4/9 is like 2/3 times its reciprocal 9/4. At this point, I could reduce this down to 3/2. So dividing fractions, change it to multiplying by the reciprocal of the divisor or the second fraction. Okay, so let's see here. How about this one? 3y over 8 divided by 3/2. That would be 3y over 8 times 2/3. But now I can reduce the 3's to 1 over 1 and the 2 over 8 to 1 over 4. In the numerator, I have 1 times y times 1. In the denominator, I have 4. So it all reduces down to y divided by 4. How about this situation? 3x plus 6 over 40 divided by 3x squared over 24. That's the same thing as 3x plus 6 over 40 times 24 over 3x squared. Dividing by a fraction is like multiplying by its reciprocal, or its refliprocal, as I like to call it. Now we can go back and we'll factor out a 3. And let's see here. Oh, the 3's here and here would reduce down. I can take an 8 out of there and an 8 out of there. And I think that's it. So what have I got? I've got 3 times x plus 2 over 5x squared, or 3x plus 6 over 5x squared. Either this or that should be correct. Okay. How about, let's see here. How about this one? X squared minus 2x minus 35 over 3x squared plus 27x, all divided by 3x squared plus 17x plus 10, all over 18x squared plus 12x. First of all, I'm going to change dividing by a fraction to multiplying by its reciprocal. So the first fraction remains the same, times the reciprocal. Okay, now we've got to factor everything. So there's that top fraction. The bottom, I can take out a 3x and I have an x plus 9. Over on the right, I can take out a 6x and have a 3x plus 2. I think that's right. And then here I'm going to get a 3x and an x and a 5 and a 2 and a plus and a plus. Now, if you're wondering how I factored that, well, consult the last chapter, okay? So now that everything's factored, let's see here. This will go to that. This will go to that. This will go to that. And that will go to that. Oh, I see that in my haste, I left out an X here, didn't I? Yeah, sorry about that. So what's left? Well, let's see, in the numerator, I've got X minus 7 and a 2. So 2 times X minus 7. And in the denominator, X plus 9. So let's see here. Any questions about that? Okay, here's another example. X squared minus 16 over X minus 4 divided by the quantity 3X plus 12. That's the same thing as X squared minus 16 over X minus 4 times 1 over the quantity 3X plus 12, because this is like that over 1, right? So its reciprocal would be 1 over 3X plus 12. So now let's see, this is the difference of 2 squares. This doesn't factor any further. Here we can take out a greatest common factor of a 3. And I can reduce out the X minus 4s and the X plus 4s, and I'm left with just 1/3. Okay, let's see here. We got more time. Let's see. This is 5X plus 5 over 25 times 5 over X plus 1 cubed. I could take a 5 out of the numerator on the left. I've got that, okay? So now 5 over 25 reduces to 1 over 5. 5 over 5 reduces to 1 over 1. So what have I got left? I've got X plus 1 over X plus 1 cubed. What if you had X over X cubed? Wouldn't that be 1 over X squared? So this is going to be 1 over X plus 1, the quantity squared. Top exponent reduces down with the bottom exponent. Questions there? All righty. Out. Let's see here. Not this one. We've got 3p squared plus 5p minus 2 over p cubed plus 2p squared divided by 6p squared plus 13p minus 5 over 2p cubed plus 5p squared. So the first thing I've got to do is change division to multiplication of the reciprocal. So 3p squared plus 5p minus 2 over p cubed plus 2p squared times 2p cubed plus 5p squared over 6p squared plus 13p minus 5. Okay. So we're going to factor everything. 3p, p, and plus 2 and minus 1. That's going to be that. This, we're going to take out the greatest common factor of p squared and have a p plus 2. Here, we're going to take out the greatest common factor, which is p squared, and have a 2p plus 5. And here, let's see, what are we going to have? How about 2p plus 5, 3p minus 1. That's not going to work, is it? Let's figure this out. Let's see. So let's take this and let's factor it. I'm going to go to the next page. 6p squared plus, is that 3p? No, 13p, okay, plus 13p minus 5. Let's see, a is 6, b is 13, c is -5, the product is -30, the sum is 13. How about 15 and -2? Yeah, so 6p squared plus 15p minus 2p minus 5. Take out a 3p and have a 2p plus 5. 2p plus 5 and a minus 1. So 2p plus 5, 3p minus 1. I think that's what I had. I guess I just didn't see it. 2p plus 5, 3p minus 1. Yes, I see what I wasn't seeing that there's 15 minus 2. Okay, so now what can I do? Well, we could have a reduction sale bigger than when Nordstrom's left town. P plus 2, P plus 2, 2p plus 5, 2p plus 5, 3p minus 1, 3p minus 1, p squared, oh, 1. Well, that was kind of a sweet deal. Out of chaos, something nice. How about, let's see here. Let's do, this one to refresh our memories. Y minus 3 over y times 3y over 3 minus y. There is that whole thing that reduces down to -1. And the y over y reduces to 1 over 1. So what have I got? -1 times 3 is -3 over 1, or just -3. Be careful when you're reducing things and crossing things out that you are clear as to what you've gotten rid of and what still remains, okay? All right, so that's it for today. You've got 7.1, reducing or simplifying rational expressions, algebraic fractions, and then 7.2, multiplying and dividing algebraic fractions. Tomorrow, we'll look at adding and subtracting. Woohoo! So I will stop the recording